Hi, you're warmly welcome back once again to my YouTube channel. This is your math tutor, Richard Oben, and I am here to help you throughout your math journey. As we are on the field trying to help students out there bit by bit so that those that their mouth house is a little bit shaking will be built well. Today too, as we said it earlier, it is our greatest aim to make sure that whoever that is having problem in mathematics with respect to his or her basis in mathematics, in the sense that it is not all that strong, we are here to help you out. That is why today too we are here to expose you to another, branch in mathematics, which if you are a student and you know it, it will help you to build your math house. So let's look at how to dive into that. We are looking at number operation, and under that, we are diving into how to find for the LCM and the HCF of whole numbers. And I believe we all know what LCM is. So LCM here means what? Least common multiples. So least common multiples and highest common what? Factors of a given pair of numbers. So over here, I have some question samples here that I'm going to lead you through. And I believe that at the end of the day, when you keep still with us, you'll be able to understand the concepts and everything will move on smoothly. So we have question number one, which is we've been asked to find for the LCM and then the HCF of 28 and 42. Are you getting me? Of 28 and 42. Over here, we are going to find the LCM and then the HCF of 28 and 42. So I have question number one, that is the number 28 and 42. I've been asked to find for the LCM and then the HCF. So the question says, what is the LCM for 28 and 42? And what is the HCF for 28 and 42? Over here, I'm going to help you throughout an easy way in finding that. Now we are going to use the idea of what? Table and division method over here. I'm going to lead you through the table and division method. How to find for LCM and HCF in a quick manner using the table and the division method. All right. So with respect to the table and division method, I am going to employ the use of prime numbers. So here I will say kindly help me list down my prime numbers here because I'm going to use them very well. So my prime numbers, I have 2, I have 3, I have 5, I have 7, I have 11, I have 13, I have 17, I have 19, and so on and so forth. So let me end here. The 3 dots here indicate that there are more of the prime numbers over there. So I'm going to use these prime numbers in accordance with what I'm going to do here now. Now, using the table and division method, I'll first of all draw my 2 tables like this. Okay, all right. Now remember, I've been given a number 28, so 28 will come to the first table. Then my second number, which is 42, will come here. Then I will draw my table nicely like that. So this is, I'm done drawing my table. Now what I'm going to do is I'm going to pick one of these prime numbers in the sense that if I pick the prime number, you should be able to divide either one of these or all the 2 numbers that I have here. So I can decide to pick the 2, and 2 can divide one of them, or 2 can divide 28 and 42. I can use the 2. I can also use the 3, which it's possible. So using the 3, if 3 cannot divide this and 3 can divide the 42 evenly without a remainder, then I can continue with that. But the question is, we want to use a prime number, said that when we use the divide, we'll be able to move onward quickly. All right, we want a prime number that can divide it in a quick manner. So here we can pick what? 7. Okay, so picking the prime number 7, 7 can divide this one easily Are you getting me? It will divide it quickly. So that is what I'm using. Though we can use the 2, but the 2 will waste our time. Are you getting me? So let's use the 7 in the first place. Now, how many times does 7 divides 28? It is how many times? 4 times. Are you getting me? When we multiply 4 times 7, we are going to get what? 28. Are you getting me? In the same manner, how many times does 7 divides 42? So I'm saying as 42 divided by 7, we are going to get what? 6. So here becomes 6. Are you with me? Very good. So here we realize that 7 being a prime number has been able to divide this and this. Look at what we are getting. It has been able to divide it quickly. Are you getting me? Very good. So here we now have 4 and then 6. But over here, we're able to use the 7 to divide the 28 and 42. So what we are going to do, we are going to stir the 7. Why? Because 7 was able to divide 28 and 42 at the same time. Okay, now we dive into the next part. We now have 4 and 6. So our next thing is we are going to pick another prime number which can divide these two numbers at the same time, or it can divide one of them at the same time. Can we use 7? No. Can we use 3? Yes, we can use 3. So I can use 3 here. Okay. Now when we come here, can 3 divide 4 without a remainder? No. So here there will be a remainder, so I will maintain the 4. So for us, it will be a remainder. I will leave it like that. Now, can 3 divide 6? Yes. How many times 2? I believe you are following. Good. So here we said that the 3 can divide 4 though, but there will be a remainder. And here the rule states that if there will be a remainder, then I will write the number as it is. Okay. Now over here, we are not going to stir the number 3 here. Why? Because 3 was able to divide only the 6, but not 4. Okay, so we are continuing. So we now have 4 and 2. So which prime number can I also use again? I can use 2. Now 2 divides 4 how many times? 2 times, and divides here 1. So here, because the 2 was able to divide a 4 and then 2 at the same time, I can now stir the 2. Okay, so now I have 2 and then 1. So I can still divide it. I can use 2 to divide this store. Now 2 goes here 1. And here 2 cannot divide 1. Okay, there will be a remainder. So I'll maintain the 1 as it is. So you realize that I am now getting 1, 1 over here. So far as I am getting 1 and then 1 here, then it means I am done. So our aim is to divide till we get 1 here and then 1 there. Now that we are done like that, we are now going to find for our HCF and our LCM. Okay, so we are done with the table through division. Our next thing is, let's see how to find for the HCF, which is the highest common factor. To find for the highest common factor, we are going to multiply the stirred numbers. So here I have the stirred numbers 2. So 2 times the stirred number 7. Okay, so I'll multiply. Now 2 times 7 gives me what? 14. So 2 times 7 gives me 14. That means that our HCF for the number 28 and 42 is 14. Are you following? All right. In the same manner, when we come to the LCM, which is the least common multiple, I'm just going to multiply all the prime numbers here. So here I have 7 multiplying 3, okay, multiplying 2, which is this, multiplying this 2. Are we good? So you realize that when we use a 7 to multiply 3, multiply 2, multiply 2. So 7 times 3 is what? 21. 21 times 2. And we have 21 times 2, which is 42. Okay, so 42 here times 2. So 42 multiplying 2. We are 2 times 2 is 4, and 2 times 4 is 8. So we are going to get what? 84. So remember our HCF we had 14. Okay, our HCF we had 14. Then our LCM now we are getting 84. So that's what we are getting as our answer for the LCM and the HCF for the two of the numbers 28 and 42. All right, so that is how to do that. In the same manner, we are going to dive into question number 2, and I believe we are following the process. All right, you realize that using the table and the division method is the quickest way in finding for the LCM and the ACF. Now let's dive into question number 2. So my question number 2, I've been given the number 12 and the number 54. So I've been asked to find for the ACF and then the LCM for these two numbers. So in the same manner, I will draw my table. So I have the number 12 here. I have the number 54 over there. So remember, we said that we are going to use only prime numbers here. And please, when you select the prime number, have it in mind that the prime number should be able to divide either one of these or all the two numbers. But have it in mind that when you are using a prime number also, choose a prime number that can divide the numbers in a quick manner. So here, what numbers should we pick? We can pick 3 because 3 can help us divide it in a quick way. Now, how many times that 3 divides 12? It is 4 times. How many times that 3 divides 54? It is what? 18 times. I believe you are clear with that. Because when we use 18 to multiply 3, 3, 8 is 24. Remember 2. And 3, 1, 3 plus 2 gives us what? 54. So that means that 3 divides 54 how many times? 18 times. Okay, now let's see what is happening here. So far as 3 was able to divide 12 by this, 3 was able to divide it, then it means I can now stir the 3. I believe it is clear. All right, so here we have 4 and then 18. We can use 3 also. Now, how many times that 3 divides 4? There will be a remainder, so I'll maintain the 4 as it is. Now, how many times 3 divides 18? 6 times. So here I'm not going to stir the 3 because 3 was unable to divide 4 without a remainder. I get me? Alright, so here I can also use the 3 again. Now 3 divides 4, still 4. 3 divides 6, 2 times. So here too I will not stir. Then here I can use 2. 2 divides 4, 2 times, divides 2, 1. So here I can stir the 2 because 2 was able to divide 4 and then 2 at the same time. I can still use the 2 again. And here we can ask ourselves, again, 2 divides 2, 1. And here, 1. I believe we are clear with that. Yes. So we are now through because we are getting 1 here, we are getting 1 there. So we can now find for our ACF. So we said that to find for the ACF, we are going to multiply the squared numbers. So the squared number I have 2 multiplying 3. And 2 times 3 is 6. So my ACF becomes what? 6 as my answer. Remember, we said the highest common factor, you multiply the squared numbers, and this is what we are getting. Let's go to the LCM. So we said that the LCM, we are going to multiply all the prime numbers there, all the prime numbers. So here we have 3, okay, we have 3 here, multiplying 3. So 3 times 3 is 9, multiplying 3 is 27. So we have 3 times 3 times 3. So 3 times, this one gives us 27. Now 27, here is 4. So we multiply 27 by 4. Here is 28, remainder 2. Now 4 to 8 plus 2 gives us 10. So it means that our LCM, we are getting 108. This then becomes our LCM. Remember, finding the LCM, we are multiplying all the prime numbers over here. So after multiplying all these prime numbers, we are getting 108. And I believe you understand that. Thank you very much. So now we are done with question number 2. So let's see how to go by question number 3, question number 4, and question number 5. Now that we are having 3 numbers over there, someone is asking me, how are you going to go about it? Don't worry yourself, everything will move on smoothly unless you continue to stay tuned with us so that you will be blessed at the end of the day. So let's dive into question number 3. So in the same manner, question number 3, I have 21, 28, and 63. So that one to have been tasked to find for the ACF and then the LCM for these numbers. So we are still using the table and the division method. So I will draw my table, and because of the 3 numbers, you have to be a little bit smart. So I have my 21 here, my 28, and my 63. Now underline it like that. Which of the prime numbers should we pick? Yes, we should pick 7 because 7 can divide it quickly. So 7 divides here 3 times, 7 divides here 4 times, and 7 divides here 9 times. So 7 was able to divide 21, 28, and 63 at the same time. So I will start. Alright, now when we come here, which prime number should we use again? We have 3. We can use 3. So here, 3 divides 3, just 1. Right? Yes, 3 divides 3, just once. Now 3 divides 4, there will be a remainder, so I'll maintain the 4 as it is. 3 divides 9, 3 times. Are you clear with that? So here, I am not going to stir the 3 because 3 was unable to divide 4 without a remainder. Okay, so let's continue. I can still use the 3 because I still have 3. 3 divides here, it is still 1. Here, it is still 4. And you divide this 1, 1. Are you getting me? Okay. So now we have 1, 4, and then 1. We can use 2 here now. We have 2, we have 2, we have 1. So here too, we can still use 2. 2 goes here, 1 here, 1 here, 1. Remember, I believe you know why I did not stir this, and that, right? Very good. So we can now find for our ACF. We said with the ACF, we are going to multiply the stirred numbers. Now, how many numbers are being stirred here? It is only the 7. So far as it is only the 7, then it means that my ACF becomes what? 7. So, because it is only the 7 that has been stirred. Now let's look at the LCM. The LCM, we said you multiply all the prime numbers here. So I'm now going to multiply 7 by 3, which is 21. 21 times 3 gives me what? 63. And 63, you see here is 4. So 63 times 4. 4, 3, 12, remainder 1. 4, 6, 24 plus that. So I'm going to get 252. So this then becomes my LCM. You can also multiply that and check whether we are not going to get that. Because multiplying this, all the prime numbers here for the LCM, we are going to get what we have here. Thank you very much. Now let's quickly dive into question number 4. And I believe you are getting the understanding bit by bit. Have it in mind that we are here and we are trying to help you understand the basis of mathematics so that your math house will be well built. I believe you are following. Right, so let's see how to dive into question number 4. Then we will move all the way through with question number 5. So question number 4 too, we've been tasked to find for the ACF of 84, 105, and then 126. So here too, I have these set of numbers over there. These set of numbers. So I'll draw my table. As you can see, I will draw my table. And the numbers are 3. So I have 84 here. I have 105. I have 126. So these are the set of numbers that I have over there. So I am now going to pick one of these prime numbers to divide it, and I'll continue with it. So which of the prime numbers that can divide this evenly? I mean, in a quick way. Which of them? Which of them? Which of them can we pick? Can we pick 7? Let's see. Let's see if 7 can work. So let me pick 7 because I like using 7 because 7 helps us divide the numbers quickly. Now, how many times does 7 divides 84? So let me use my long division here. 7 goes into 8, 1. So here becomes 7. You subtract, you are getting 14. So here 2. That means that 7 goes into 81 12 times. Yes. So here 7 divides 84 12 times. In the same manner, let's check the 105, which is the 105, using the long division. How many times does 7 divides that? So 7 here, 105 over there. 7 goes into 10 once. So remember 3. Then 5 comes and joins. So it means it goes there 15 times. Right, yes. So 7 goes into 105 15 times. We do check for 126. How many times does 7 goes into 126. I have 126 here. So 7 goes into 12 once. 7 goes into 12 just once over here. So 717, a remainder of 5. Then we add a 56 to it. 7 goes into 56 8 times. So here becomes 18. And I believe we are clear with that. All right. So let's continue with that. So we are going to divide continuously till we get 1 over here. So 7 had been able to divide this and this at the same time. So therefore, we are going to say the number 7 over there. And I believe you are clear with that. Good. So we now have 12, 15, and 18. Which other prime numbers can we use again? We can use 3. Yes, 3 comes here. Now 3 goes into 12 how many times? Definitely 4 times. 3 goes into 15 how many times? Definitely 5 times. What about this? Yes, so we can now say the 3 also, because 3 was able to divide this one all through. We now have 4, 5, and 6. Which of the prime numbers can we use again? We can use the 3 again. So here is the slow 4, here is the slow 5, and 3 goes into 6 how many times? 2 times. 3 can divide 4, but there will be a remainder. That is why I maintain the 4. So have it in mind, anytime that a number can divide the number with a remainder, please rewrite the number as it is. 3 can divide 5, right? But there will be a remainder. That is why I maintain the 5 as it is. All right, so we continue with the next prime number, which is 2. So 2 goes here 2. Here it is still 5. Here is 1. I can still use the 2. Here 1, here 5, here still 1. Then here I can use the prime number 5, right? Yes. So when I use the prime number 5, here becomes 1, here becomes 1, and here still becomes 1. So I am now getting 1 here, and then 1 there. And you know why I did not set the 5, the 2, and then the 2, as well as the 3 here. Right. So let's quickly find for our HCF. We said find for the HCF, we are going to multiply the squared numbers. So we have shared this number, we have shared this number. So we are going to multiply, which is 7 times 3, which is 21. So our HCF becomes 21. And I believe you understand. In the same manner, finding for the least common multiple, we are going to multiply all the prime numbers here. So let's multiply all the prime, including the squared numbers. So this by this is 21. 21 by this gives us what? 63. Yeah, 63 times 2 gives us 63 multiplying 2 gives us 126. That is 63 multiplying 2. We are going to get here 6. So we are going to get 126. Now 126 times 2. So we are getting 12 here. This one is 5. This one is 2. 252 times 5. We are getting 10. Remember 1. So 5 are 25. That is 6. 5 to 10. So we are getting 1,260 becomes our answer. That is after multiplying all the prime numbers here, we are getting 1,260. So that then becomes the answer for our LCM for the pair of numbers, which is 84, 105, and 126. Thank you very much for staying tuned with us, and I believe you are being blessed by now. All right. Have it in mind that, as we said it earlier, when you find this video helpful, don't hesitate. Kindly share it among your colleagues out there so that we all come together and learn together as a family. Make sure you subscribe to this channel, because the more you subscribe, the more you like, you comment, and then you share, then you help us grow. Then you help us to get to know that indeed you cherish this video. Kindly stay tuned. Do not forget to subscribe so that always you will get in touch with such videos. All right. My name is Richard. I'm your math tutor. Have it in mind that I've given you a question to try your hands on. That's question number 5. It is 150, 120, and then 180. We are still using the table and the division method. Thank you and have a blessed day. Bye-bye.